So hello students, this is my third video lectures on the chapter 3. The name of the chapter is Matrices, and here I am going to discuss about elementary operations or transformation of a matrix. So students, first of all you should know that how elementary operations of a matrix can be done. So here there are 6 operations on a matrix, 3 of which are due to row operations and 3 due to column operations, which together known as elementary operations or transformations. So students, first one is the interchange of any 2 rows or 2 columns can be done. For example, ith row and jth column can be interchanged in any matrix, and similarly, ith column and jth column can be interchanged. For example, first row and second row you can interchange, or first row or third row you can interchange. For example, first column, second column also you can interchange. So this is the first operation. Second operation is you can multiply with any particular row or any particular element by any non-zero constant, non-zero real number. So for example, here Ri can be written as Kri. What is K? Is a real number. Ci tends to Kci. Any column can be changed like this. Next operation is the addition to an element of any row and column. Okay students, we can change any particular row or any particular column by using the adding the other rows or other columns with a constant multiple also. Ri can be changed as Ri plus Kri. K is a constant, and K into Ri means K into Rj, jth row. Ri, ith row plus K into jth row. We can do like this, or in case of column, ith column can be changed Ci plus Kcj. K is constant, Cj is jth column. So like this we can make the changes in a matrix. These are called the elementary operations of a matrix, and using this we can find the inverse of a matrix, which we are going to discuss. Next, what is an invertible matrix? The students, a matrix is invertible when suppose a matrix A is a square matrix, and if B is the another matrix which is the inverse of A, then the product of these two matrices must be an identity matrix. Like this, AB equal to BA must be I. It's an identity matrix. Then B is called the inverse of matrix A, and it is written as A inverse. One example is mentioned here. A is a matrix and B is a matrix. When you multiply these two matrices, and we'll get the answer is I. Similarly, BA also, it's an identity matrix of 2 cross 2. Its answer is I. Then you can say that B can be written as A inverse. So I hope students understood what is invertible matrix. Next, there is an important theorem. Its statement is inverse of a matrix, if it exists, is unique. Means every square matrix have only and only one inverse. So in order to prove this, let us take that particular matrix A having 2 inverse, and these are B and C. So we are going to show these two matrices are unique, means same. So since B is the inverse of A, so you can write AB equal to BA equal to I, and since C is the inverse of A, so you can write AC equal to CA equal to I. Thus we can write B equal to BI. We can write B equal to BI because any matrix can be multiplied with the identity matrix and the result will be same. The same matrix. So in place of I, we can change AC. I can be changed as AC because AC equal to I. Then BA you can put in one bracket into C. Again BA is I here. So I into C is again C. So you can see that B equal to C. So we have considered two inverse of A, and at last we got the two inverse are same, B equal to C. Hence you conclude that the inverse of a square matrix is unique. There is another very important theorem. If A and B are invertible matrices, then AB inverse can be written as B inverse into A inverse. So this is very important results. Now students, we are going to discuss how an elementary operations can be done. So there are two ways can be done. If a matrix A inverse exists, then to find A inverse using elementary row operations. So we write A equal to AI, and when you write A equal to IA, I into A equal to I into A, then we have to do the row operations on this system, and we start the system continue the system until we get this I. This A is an identity matrix, and when this A will change, simultaneously this I will change. So this I will change to some other matrix, and this will name as B. So I equal to BA, it will be form. Then we can say that B is the inverse of A. Similarly, we can do the column operations. For this we have to write A equal to AI. So remember students, for column operations we have to write A equal to AI, and for row operations we have to write A equal to IA. So when you write A equal to AI, we have to do the column operations, and we make this A to identity matrix, and this A and this I will change here, and this I will change to some other matrix B. Then we conclude that B is the inverse of A. Now in case after applying the row or column operations for a particular matrix for getting inverse, if we get any particular row or column, all the elements are 0, then we conclude that A inverse does not exist. So I hope students you understood what is elementary operations. Let us move to some related questions based on this concept. Using elementary transformation, find the inverse of each of the matrices if it exists. The question is in first column 1 2, second column 3 7. So students, we are going to do using row operations here. So when you do the row operations, we should write A equal to IA. So when you write A equal to IA, the matrix A is given 1 2 3 7, and I is the identity matrix 1 0 0 1, and A is this given matrix. And we don't write the matrix A here. We'll only write A, the matrix A given in the left hand side. Then we start the system. Our aim is to make this matrix as identity matrix of order 2. Then we should make this 2 entry 0, and this 2 entry 1 1 0 0 1. So in order to do that, first we will change R2, 2 minus 2. So if you multiply first row by 2 and subtract from second row, then we will get this entry 0. So you are doing R2 tends to R2 minus 2 R1. So 2 minus 2, this R1 is not going to change, R2 is going to change. So 2 minus 2 is 0, 7 minus 6 is 1. Similarly here also same, 0 minus 2 is minus 2, 1 minus 0 is 1. Similarly, in this matrix we have to change this 3. So if you do 3 minus 3, then we will get this entry 0. So we have to do R1. We are going to change R1 as R1 minus, we are going to change R1, that R1, and this R1 we are going to change using R2. So you have to multiply this by 3. So when you multiply this by 3, then this entry becomes 3 minus 3. So you can see that R1 minus 3 R2. So R1 minus 3 R2, 3 minus 3 becomes 0, and here 1 minus 6 becomes 7, and 0 minus 3 becomes minus 3. And you can see that this matrix is an identity matrix, and this identity matrix is changed to some other matrix, and this is named as B, and this is nothing but the inverse of the given matrix A. So I hope student you understood. Let us consider one more question here. First to write A equal to IA. Here also we are going to do it by row operation. 3 minus 4 minus 1 2 equal to 1 0 0 1. Then we have to make this two entry 1 1 and this two entry 0 0. So accordingly we have to do the sum. So R1 is going to change 3 R1 plus 2 R2. So R1 is going to change 3 R1 3 R1. If we if we multiply this row by 3 and add this row add this row and multiply this row by 2 and add, then we will get this is 1 and this is 1, this is minus 4, this is 2. Then if we apply this operation, R2 tends to R2 minus 4 R1, then R2 will change like 0 6 and 1 1. Similarly R2, if we change 1 by 6 R1, because here 6 is 0 6, 6 is common factor in second row, so we can divide this R2 by 6. So R2 is going to change 1 by 6 R2. Then if we subtract R1 minus R2, R1 minus R2 if you do, then R1 will change, this entry becomes 0, then 1 0 0 1. Similarly accordingly this identity matrix also will change, and at last the required matrix will be this is the inverse of the matrix, given matrix A. Now here students, there is a 3 cross 3 matrix. Similar manner we have to proceed. We first will write A equal to IA. Doing the row operations, A is a given matrix, 2 minus 3 3, 2 2 3, 3 minus 2 2, and this is the identity matrix into A. Now first operations we are doing, R1 is going to change R1 plus R2 minus R3, means adding R1 R2 and subtracting R3. So see, 2 plus 2 4, 4 minus 3 1, minus 3 plus 2, this is minus 1, and minus plus 2 1, 3 plus 3 6, 6 minus 2 4. Similarly this also we are going to do. Second R2 we are going to change R2 minus 2 R1. Second row is going to change R2 minus, multiplying first row by 2. So 2 minus 2 0, 2 minus 2 0, 3 minus 8 minus 5. Then R3 is going to change R3 minus 3 R1. This R3 is going to change R3 minus 3 R1. So 3 minus 3 0, minus 3, minus 2 minus 3 minus 5, 2 minus 12 is minus 10. Then interchanging R2 and R3, these two are interchange. These two rows are interchange. After that, see, there is 5 is common, so you can take you can divide R2 by 5 in the next step, dividing R2 by 1 by minus 1 by 5 R2 and R3 by minus 1 by 5 R3. Then you will get like this 1 1 4 0 1 2 1 1 0. Then R2 is going to change by R2 minus 2 R3. This R2 is going to change by R2 minus 2 R3. So 2 into R3 means this become 2. So 2 minus 2 0 here, and rest to the same because here is 0. So next we are going to change R1 by R1 minus R2. Okay students, so R1 minus R2 is this entry becomes 0, R1 minus R2 is 0, 4 minus 0 is 0. Then lastly what we will do, we have to make this entry 0, so R1 minus 4 R3. So R1 going to change by R1 minus 4 R3, so actually our aim is to make this matrix identity matrix. So we got it's an identity matrix. Similarly the operations what we made here, same operations we have to do here. We have to be very careful about its calculations, and at last we got a matrix here which is change matrix of identity matrix, and this is the required matrix, which is the inverse of the given matrix. So I hope students understood the technique of elementary transformations of finding inverse of a matrix. Here I am giving some questions. All of you please try it yourself, and if you have any questions, any doubt, you can contact me. Thank you very much.